So, hello everyone, welcome to this lecture. Today we are going to do the part 5 of atomic structure, and that is going to be the second last or third last lecture only. Okay, in the last lecture, what we have discussed, first let us have a view of what we have discussed in the last lecture. So, in the previous lecture, we have discussed Bohr atomic theory, where we have seen about the energy, the postulates of Bohr. Then we have seen about the energy difference. Then we have seen this. Then I have given a homework that was, why does H2 give so many spectral lines despite having only one electron? What will be the answer to this question? Anybody has researched? I don't see any comments. So I don't think so anybody has researched on this question. So what is the answer of the question? The answer of the question is a very simple one. You see, hydrogen has many electrons. Hydrogen has many electrons. What do I mean by that? Sorry, not electrons. Hydrogen has many atoms, right? Not electrons, sorry. So every atom absorbs different amount of energy. So every atom absorbs different amount of energy. Now, if every atom will absorb different amount of energy, then they will get excited to different states. Therefore, they get excited to different states. Therefore, they get excited to different states. So, if they are getting excited to different states, the number of spectral lines will increase. Clear? This is the reason. You all should know. Done? Lyman series, 1 by constant bracket T and quick fund series. I have told you which region, which one is dragging. Done. Number of spectral lines is again I gave you. The number of spectral lines formula is N2 minus N1 into N2 minus N1 plus 1 by 3. Right? Energy of nth orbit, very important formula. Radius of nth orbit, very important formula. Velocity of nth orbit, and number of revolutions. These are required for JEE and mostly. Clear? So this was all that we had discussed in the previous class. What today we will discuss is, let us have a look at what we will discuss today. So today we have defects of Bohr model, Heisenberg's uncertainty principle, de Broglie hypothesis, Schrodinger wave equation, orbit-orbital concept, and the introduction of quantum numbers. Quantum numbers I will be taking up in detail in the next class, not today. Okay? So let us begin with our first topic, defects of Bohr model. Defects of Bohr model. Now, in the last lecture, I have discussed about the postulates of Bohr model and the merits of Bohr model. That means the postulates were actually merits, but it's not like that Bohr model is fully good. No. Everything has some or the other defects. So similarly, Bohr model also had some defects which need to be worked upon. That is why came the concept of wave mechanical model. Now, this Bohr model, all the things we have done in the previous lectures, those all were applicable for a uni-electron system. If you go for a multi-electron system, it will not be able to be applied. Clear? Clear? So first and foremost thing is, unable to explain atomic spectra of multi-electron species. Unable to explain atomic spectra of multi-electron species. Multi-electron species. Means what? Bohr model will be able to explain the atomic spectra of hydrogen. Hydrogen has only one electron. Lithium 2 plus, it can explain that. Okay, helium plus, it can explain that. But it cannot explain sodium plus or sodium. This it cannot be. Why? Because it does not have one electron inside it. So Bohr model's first and foremost defect is only and only one electron which it can explain. So unable to explain atomic species of multi-electron system. Clear? Understood? No doubt. Second one is fine spectrum. That is ultra fine spectrum. Unable to explain ultra fine spectrum. Second point is unable to explain ultra fine spectrum. Unable to explain fine spectrum. High spectrum means more dense spectral lines. Okay, that is not being able to explain by Bohr's model. Clear or not clear? Then next, and number three, sorry, the most important one. Number three is the most important one. Okay, most important one. Unable to explain effect of magnetic unable to explain effect of magnetic field, magnetic and electric field on spectrum, on spectral lines of atom. Okay, an atom is receiving spectral light. Very good. Now, if we are passing it through magnetic field or electric field, what will happen to that? That he has not said. But something happens, but he did not say what is happening. So that was one of his defects. So what exactly happens? That also we need to know. So you have to know about two terms. What are the two terminologies? First one is Zeeman effect. What effect? Zeeman effect. Zeeman effect. And another one is Stark effect. Zeeman effect, Stark effect. The two effects are very much important and you have to memorize these two effects. One is Zeeman effect, one is Stark effect. Very, very important effects. Okay. Stark effect stands for electric field. That means this effect you will get in electric field. When you go for Zeeman effect, you will get this effect in magnetic field. Okay. Now what happens exactly? When you pass this spectral lines through magnetic field or electric field, what happens is the spectral line will get split. Okay, so the splitting of spectral lines, what is happening? The spectral lines split. So splitting of spectral lines, clear? So splitting of spectral lines. Now if these spectral lines are getting split in a magnetic field, is Zeeman effect. If it is in the electric field, it is called Stark effect. Clear? But these are not said by Bohr's model. That is what the defect of Bohr's model. Clear or not clear? Clear or not clear? Understood? Zeeman effect. Understood? Stark effect. So third demerit of this is unable to explain the effect of magnetic electric field on spectral lines of atom. That is two effects, Zeeman effect and Stark effect. Done. Next. Next you find out when Bohr made his study, electron was considered to be a particle. That means electron was thought that it would be revolving around specified parts called orbits. But recent studies, or for the modern studies, then modern studies do not support the view. What does modern studies say? That electron is both a particle as well as a wave. The modern studies do not support this statement. They say that electron is both a particle as well as a wave. So we have to take into that consideration as well. So that is also a demerit of Bohr's model of atom. Clear? So the next demerit we will write it as the color. Next demerit we will write it as we'll write this as advanced studies. Advanced studies suggest electrons to be both particle and wave. However, Bohr assumed it to be only a wave. Bohr's model assumed it to be particle or discrete particle. That's why I will write the word discrete particle. Clear? So actually an electron has both the particle and wave nature, but in the Bohr's model, he has assumed it is only going to have a particle nature. Clear? So that is an exception. So if it is not having any particle nature, if it is a wave, then it must not have a defined orbit. We will come to know about that. When we talk about orbital concept, we will explain that. Orbits are defined, but orbitals will not be defined, right? So the orbits should not be defined if it is a wave. That we will talk about in the later part, okay? Then comes Heisenberg's uncertainty principle. Heisenberg's uncertainty principle. Okay. Next and the biggest defect is Heisenberg's principle. Heisenberg's uncertainty principle. According to Heisenberg's, the momentum and position you cannot simultaneously determine. Okay. Please do not write it in a statement. I'm just saying. Okay. So Heisenberg's uncertainty principle. This principle states that simultaneously it is not possible to determine the position as well as the momentum of the electron. But Bohr has already done that. How? He has to rotate it. The electron is revolving around in an orbit. So automatically the position as well as the momentum at the instant is clear to us. So that is not possible. That is also one of the setbacks. Clear or not clear? Then last one is combination of molecules. Okay. Mode of formation of molecules. Unable to explain the mode of formation of molecules. Unable to explain the mode of formation of molecules. Unable to explain the mode of formation of molecules. Unable to explain mode of formation of molecules. That means why exactly atoms combine to form molecules, this was not told by Bohr. So these are the list of effects of Bohr's model. So repeating again, summarizing again, Bohr's model is not applicable for multi-electron species. Bohr's model does not explain fine spectrum. Bohr's model does not explain the effect of this magnetic and electric field on spectral lines. Advanced studies support electrons' dual nature, but Bohr has assumed the discrete particle nature. Heisenberg's substitution was an exception to Bohr. And last one is mode of formation of molecules, which is not explained by Bohr's atomic model. Clear? So saying all these things, we had to discard Bohr's model. Not completely, but partially we had to do it. Then, so the next model that we are going to study today. So Bohr's model we have done. Bohr's model discussion done. Then next comes de Broglie hypothesis. I am doing first. Heisenberg I will do a little bit later. Okay. First, let us do de Broglie hypothesis. So next topic that we will be coming up with is de Broglie hypothesis. De Broglie hypothesis. De Broglie hypothesis. See, de Broglie hypothesis, he suggested that not only electrons, सिर्फ इलेक्ट्रॉन्स ही नहीं, कोई भी पार्टिकल आप क्यों ना ले लो, उसके पास डुअल नेचर है. मतलब इस लैपटॉप के पास भी है, मेरे पास भी है, फोन के पास भी है, बुक के पास भी है, फुटबॉल के पास भी है, कोई भी चीज हो, सबके अंदर वेव पार्टिकल दोनों कैरेक्टरिस्टिक्स है. ठीक है. पर जो हमारे पार्टिकल दिख रहे हैं हमारे सामने, सपोज हम मान लेते हैं ये किताब एक पार्टिकल है. क्यों पार्टिकल है? क्योंकि उसका जो वेवलेंथ है वो बहुत कम है, नेग्लिजिबल है, इसीलिए वी आर नॉट कंसीडरिंग द वेव. बट इलेक्ट्रॉन्स वेवलेंथ इज क्वाइट मच no, not negligible, it's quite much, so you have to consider it. So it is both a particle as well as a wave. Clear? So de Broglie hypothesis, we have the formula that you have to memorize. What is the formula? So the main formula for de Broglie hypothesis is wavelength calculation is wavelength equal to h by rho, where rho stands for momentum. Okay. So I can also write this equation as, or what I can write, lambda equal to h by mv. Clear? This is the direct formula. Now we will see in some twisted format question, neither mass nor velocity but kinetic energy is given. So that case you have to use your physics knowledge. You know that P is equal to mv. You know kinetic energy equal to root over 2. You know it is equal to p square by 2m, right? And p is equal to root over 2m. These are the formulas that you can use. 2mke. So this knowledge that you have in physics will be using this. So lambda I can also write it as h by root over 2mke. This equation also you will be getting to use in many of the equations. Clear? This formula you will be using in some of the questions where you will find angle energy given in the question. Clear? So that is direct. Now, from here what can you see? From here what will you see? H is a constant. Do you all know what is H? If you all don't know H, I am writing here, okay? H is nothing but Planck's constant. H is Planck's constant, okay? Planck's constant, value is also constant, 6.626 into 10 to the power minus 24 joules second. Constant value, right? Now, you find that this H is a constant, so automatically I can write lambda proportional to 1 by this. Tell me, clear or not clear? Lambda proportional to 1 by momentum. Clear? So more the momentum, lesser will be the lambda value. So that is our momentum is more due to our increase in mass. So automatically our lambda is less. So we are not going to get a wave nature, but we have a wave nature. Okay. Let me show you with an example. Fine. I am having a mass of 150 gram. Let us take I am having a ball of mass 150 gram. Fine. And let us take a velocity is 2500 centimeters per second. Right. So what will be the wavelength of the body? If I am taking this, then what will be the wavelength of the body? Then wavelength of the body will be h by mv, right? So h I will consider in 6.626 into 10 to the power minus 27 divided by 2500 into 150. Why is minus 27? Just now I wrote minus 34. Then why it become minus 27? Because of the unit. Unit you have to take care. One is gram, one is centimeter. So ultimately 5 you have to decrease. So that is why I have decreased 5 over the main. Clear? 5 plus 2, 7. Ultimately to decrease 5 and 2, 7, right? I there 7. So totally you have to decrease. That is what I have done. Okay. So 27 is the unit in centimeter. Okay. That means joule second. The joule you have come to 9 centimeter. There you have to write. Clear or clear? No doubt. Because 9 centimeter of vibration. 9, Newton 5 and centimeter meter 2. So 7 will decrease. No problem. So this is the value. Now upon calculation of this, what is the value you are getting? You are getting a value called 1.67. 1.767 into 10 to the power minus 32 centimeter. Minus 32 centimeter. So you now see, you check. This wavelength, is it very, very less? Minus 32 power, that means 0.0000 around 29 zeros. So you can imagine 29 zeros will be there. So that is what? That is almost 0 only. So is there even a considerable value? So this wavelength is very, very less. Wavelength is very, very less. So particle nature predominant. So particle nature predominant. That so particle nature predominant. Why is particle nature predominant? Because lambda value is very, 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 very small. So why will be considered a wave nature? So automatically the particle nature is clear. So this ball or this substance, whatever it is, it will behave as a particle, not as a wave. Then now let us take the case of an electron. Let us take the case of an electron. So what is the mass of an electron? 9.1 into 10 to the power minus 31 kg. What is the velocity of electron? Okay, let us take a velocity of electron. 2.19. 2.19 into 10 to the power minus 8. 2.19 into 10 to the power minus 8. What minus it? 2.8. Okay, 8. 8 centimeter per second. So we will consider this in gram. 10 to the power minus 28. Clear? Now find out lambda. Lambda will be h by mv. So 6.626 into 10 to the power minus 27 divided by 2.19 into 10 to the power 8 into 9.1 into 10 to the power minus 28. So ultimately upon solving you will get 3.32 into 10 to the power minus 8 centimeter. Now you see this thing and this thing. This thing is still considerable amount, but this thing is not at all considerable amount. Here lambda is not very much less. Lambda is not very much less. Okay, lambda meaningful. Lambda value is still meaningful, not very, very less. So both wave and particle. Now you will say, then let's consider variable. No, particle nature we cannot ignore. It has a velocity, it has a mass, it has to have a momentum. So particle nature we cannot ignore. But wave nature also we cannot ignore. It is both a wave and a particle. Clear? You have seen the difference in case of a bigger object. You can see it is very less wavelength. So we are not considering the wavelength part. Clear? But here in this case, it is going to be meaningful. So we will be considering both wave and particle nature. Clear or not clear? Any doubts? Put in no doubts. Done. Okay. Then we move on to the next topic. So this one is done. Done. Next is Heisenberg. Before moving to Heisenberg, let us do one numerical from this part. I think I have one numerical. This one. So let's do this numerical. What is the question? I will not be solving it, solving calculation that you all can do also. I will just give the hint of how to solve the question, right? So how to solve the question? An electron is moving with a kinetic energy. So see, kinetic energy is given in the question. Kinetic energy is given in the question. 4.45 into 10 to the power minus 25 joule. Asking for de Broglie wavelength. H given in the question. Question mark I am writing, but it is given in the question. H given. That you have to know. That will not be provided in the question. So what lambda formula will use? Lambda equal to 8 by root over 2mke. Right? Electron is provided. So mass, you all should remember that mass is 9.1 into 10 to the power minus 31 kg. Right? So this mass you all should remember because maybe given in the question, may not be given in the question. Then you have to just use this formula, that is value will substitute divided by root over 2 into 9.1 into 10 to the power minus 31 into 4.55 into 10 to the power minus 25. Solve it and you will get one answer in meter. The answer that will get in meter, that will be your answer. Clear? Solving I am not doing, you can solve it. Clear? So from the question intermediate, K is given, H you already know. Remaining a mass is given because of electron is given. Electron's mass you all know. So you are going to put the value of mass and you are going to get the answer. Understood or not understood? Done? So that ends this part. Now we are moving on to the next part, that is for Heisenberg's uncertainty principle. Heisenberg's uncertainty principle. Heisenberg's uncertainty principle. Now, let us discuss about Heisenberg. Heisenberg's uncertainty principle, the question that will be asked, first question will be asked is statement of Heisenberg's uncertainty principle. So let us write the first statement. Statement, please do not change any statement. Modifying statement, no need. Whatever is given, just copy paste. No need to make up any sort of statement. Clear? So write down the statement. It is impossible or not possible, whatever, that is English. It is not possible to simultaneously determine both the position and momentum only. Do not write velocity because that is a derivation. That is a deduction from the main statement. Actually is position and momentum. No velocity is supposed to be detailed. Position and momentum of a moving microscopic particle. If you write electron gone, moving microscopic particle with absolute accuracy. So few points I need to highlight over here is this word, moving microscopic particle. Do not end up writing electron or do not end up writing particle, moving particle. That is a macroscopic particle. Then the original answer is not applicable only. Moving microscopic particle, you have to mention in your answer. That is one of the main parts. First part is position as well as momentum. Second is microscopic particle. You have to write, otherwise gone. Clear? What is the mathematical representation? Mathematical representation, if I represent delta x by the, I am giving you the formula, delta x dot delta p greater than equal to h by 4 pi. Remember, when you are going to solve the question, it will be equal to, but the main formula is greater than equal to. But when you have to solve, it is going to be equal to. We are not solving inequality. We are solving inequality. That will be equal. Clear? So the main formula for mathematical representation for Heisenberg is this. Main derivation is this. Now from this direction you can write P delta B because M delta B, because M won't change, so M can go down. So there you get another formula is delta x into delta B greater than equal to h by 4 pi M. But that is not the main formula. That is the derived formula from here. So mathematical original mathematical representation is delta x dot delta P greater than equal to h by 4 pi. So do not try to do anything else. Whatever is given, right there. Clear or not clear? Clear or not clear? Clear? Any doubt? Any doubt? Achha, what is this delta x delta p? This is uncertainty in position. This is uncertainty in position. Uncertainty in position. What is this? Uncertainty in momentum. Uncertainty in momentum. Uncertainty in momentum. And what is this? This is uncertainty in velocity. Okay? This is uncertainty in velocity. In some question you might be given to find out uncertainty in velocity. In that case we will be using that, otherwise not to do it. Clear? Okay, this is all about Heisenberg. Little bit part is there, nothing very huge, this and that is there. This bit part is there, agree to go. Heisenberg understood. So we have completed another topic, it is Heisenberg. So Heisenberg also done. The topic discussed. Next coming to Schrödinger wave equation. Before that, there is one numerical from Heisenberg. Heisenberg one numerical we need to do. So research. You can go. Question. Question is asking calculate uncertainty in momentum. So what is being asked? Momentum. So we have to find delta P. Okay, fine. What is given? Electron is given. Uncertainty position is given as 1 angstrom. So delta X is given to us as 1 angstrom. Remember always, students. Remember always. Angstrom given, always you have to convert to the SI unit. Angstrom if you use will get a wrong value. So 1 angstrom you cannot use. You have to convert it to the SI unit. So 1 angstrom is how much? Meter. 10 to the power minus 10 meter. That relation also you remember. That also you remember. So 1 angstrom 1 to the minus 10 meter. Now delta and delta P you have H. 1 4 pi do you already know. Fine. Clear? So which equation you are using? Delta X or delta P greater than equal to H by 4 pi. Greater than equal to will not use. So ultimately I am getting delta P equal to H by 4 pi delta X. That is 6.626 10 to the power minus 34 divided by 4 into 3.14 into delta X is given as 10 to the power minus 10. Thus, solve this equation and you will be getting one answer. That will be the answer. And the answer will come in which unit? See the unit. Momentum is asked. So answer must be in kg meter per second. And the answer must be in kg meter inverse. Okay, done. Oh, next Schrödinger wave equation. Next is Schrödinger wave equation. Schrödinger wave equation. Schrödinger wave equation. Only the equation is to be read, not now. So only the equation I am going to discuss. Schrödinger wave equation is as follows. Del squared psi, okay, plus 8 pi square m by h square, 8 pi square m by h square, bracket e minus v psi equal to 0. This is the only thing we need to read for now. Clear? Del square psi plus 8 pi square m by h square e minus b psi equal to 0. This is just Schrodinger equation. Okay? What is this del square? This is read as del square. Okay? Del square. Read as del square. This del square is actually another big value, which is actually not to be read. It is actually 3x square. See, y actually equal to this square y x square plus this square y this y square plus square y x square. This is actually del square value. So instead of writing this long equation, we have substituted by writing the del square. Clear? So understood? Schrodinger wave equation. Only these two things you have to remember, and this you have to learn. So what will you do with this? You have to learn. Clear? So you have to learn these two equations, Schrodinger wave equation and this one. Del square is not required, generally not required, but the Schrodinger equation, main equation you have to learn. Okay, this you have to learn. So this is a very important equation, Schrodinger wave equation. Okay, so we have done Schrodinger wave equation as well. So Schrodinger wave equation now. There is only the wave equation you have to study. Nothing else is history, geography is not the next level. Next come orbital orbit concept. Let's move on to orbital concept. Orbital orbit concept. Till date you have been knowing about orbits. Till date you have known about orbits. Orbits, orbitals. So first let me little bit discuss about orbits. Then I am coming to orbitals. Orbitals. See. What is orbit? Till date you have learned about orbit and you have understood that orbit is nothing but this structures. See. Diagram structures, orbits. Till date you have understood that these are orbits. This is one circle, inside which there is another circle, there is a concentric circle, then another circle, now inside is another circle. This way you have understood that these are called orbits. This way you have understood orbits. So this is one orbit, this is one orbit, this is an orbit. So the first and foremost thing about orbits is circular. Orbits are what? Circular. Orbits are circular. Now you understand. Circular orbits means, will it have any particular direction? Circular orbits will have any direction. A circle can have any direction. Circle cannot have any direction. So these are all non-direction. What are these? Non-direction. A circle cannot have any direction. So these are non-directional orbits. Clear? Okay. So these are the basic points I am telling you. Orbits will be circular, non-directional. Another point that you will be writing, not me, definition of orbits. Definition. What is the definition of orbit? The well-defined circular path in which electron can rotate. Electron can revolve or rotate. Rotate will be a bad word. Revolve only. Electrons can revolve around the nucleus in Bohr's model. In Bohr's model. Clear? So that you will be writing, that I am not writing. Then circular, non-direction. Clear or not clear? Any doubt? Now, electrons moving in an orbit is against Heisenberg. Against Heisenberg. So, movement of electrons in orbit violates Heisenberg's principle. Violates Heisenberg's principle. Clear? Okay. And last one, max electron. Tell me, what is the max electron in an orbit? Max electron in an orbit. The maximum electron in an orbit is given by 2n square, where n is the principal quantum number. Where n is the principal quantum number. That is why I said a little bit quantum number introduction I must give. Principal quantum. Okay. So for orbits we have discussed. Definition will be 1 point. Circular, non-directional, movement of electron against Heisenberg's principle. Maximum electron will be by 2n square. Clear? Where n is the principal quantum number. Next, coming to the next term, orbitals. What are this? Orbitals. Seems like orbits and orbitals are same, but actually orbits and orbitals are not same. The first and foremost thing we'll do is a definition of orbital, which I am going to give you because you all don't know what is an orbital. Okay, so I am writing a definition here. So see, orbitals, if we have seen the structure, you will find that around the nucleus, in wave mechanical model, around the nucleus there are some specific parts, there are some specific points where electron cloud is found. Those points are called orbitals. So it is actually nothing but the three-dimensional space, the three-dimensional space, the three-dimensional space around the nucleus, in which probability to find electron is maximum, in which probability to find electron is maximum. This is called orbital. Clear? One thing I did not mention here, one important thing you please mention, I forgot. I am telling you now. Psi. This psi square, this represents probability density. What does it represent? Probability density. That means probability of an electron to be found at a place. Okay, in a particular area, if you want to find out the electron, then that is called probability density, psi square. Okay, and if I write psi only, then that is amplitude of electron wave. Okay, and that is amplitude of electron wave. Clear? These two terms I forgot at that time. I am checking. Psi square is probability density and psi is amplitude. Done. So here probability density is probability to find electron. That means what? This means what? That psi square will be maximum. Clear? So if psi square is maximum at a place, we will say that to be an orbit. Clear? Done. Now coming back to here. Circular. So this will be circular. Maybe circular, may not be circular. Okay. Sphere. What am I writing? Orbits are circular. May be circular, may not be circular. So distribution of charge flow different to different shapes. So different shapes. Circular, but here it is not only circular, maybe different shapes due to different distribution of electron cloud. Electron cloud is differently distributed. Distribution of electron cloud. Okay, the shape can be this shape. The shape can be this shape, double dumbbell. The shape can be a sphere. The shape can be a complex shape, this is orbital. This is called p orbital. This is a p orbital. This is a d orbital. Okay, and this is a f. Right, what am I writing? F orbital. S orbital. Okay, and f orbital is also there. This I cannot draw because it is very huge. Okay, very complex structure. So clear? So, now coming back. See, circular orbits differentiate with different distribution electron cloud. Next point I have written is non-directional. So will they be directional? Yes, because this can face one direction, as can face this direction. So they are directional. So next point is direction. Bracket. Important thing I am writing, exception. S orbital is non-directional. Again the same reason. S orbital is non-directional. What is the reason for that? It is a spherical reason. It is spherical. This. So again, if they are not having a direction, why will this have a direction? That is also sphere. Clear? So S orbital is non-directional. Others are directional. Clear? What was the next one? If you write movement of electron violates Heisenberg's principle. So concept of orbital is in accordance. So here does not violate Heisenberg's rule. Does not violate Heisenberg's rule. Clear? Last point, maximum electron. Very, very important. Maximum electron that one orbital can accommodate is 2. Many a time we will find even in JE only, I think. But long back, question used to come directly. In Neet it comes every year more or less. How electron maximum in S orbital, 3s orbital, 3p orbital. But all this one orbital, if it is mentioning, it will have always 2 electron maximum. If it is mentioning the 3px, maximum is 2 only. How can it have more than that? If it is mentioning as 3p as a whole, then it is 6. Okay, maximum number of electron in an orbital is 2. That is a 3p subshell. Clear or not clear? Understood? So maximum electron in an orbital has to be. It will be 2, it has to be 2. Done. So this is the concept of orbit and concept of orbital. So we have seen orbit is something different, orbital is something different. 3-dimensional and one is 2-dimensional. Clear? Next I am going to give you a brief idea of quantum numbers. I will just give an introduction, I will not go in details. Quantum numbers. As we know, the presence of electron is a wave, so we need to, how will we locate and how will we give a property of something or whatever we need to do. How should we give them? We need some we need something to tell us about where the electron is, what order. Just now we learned about orbital. How will we distinguish between this orbital, which orbital is what? So for that I need certain numbers. Those numbers are called quantum numbers. Okay, so what are quantum numbers? Numbers that designate and distinguish atomic orbitals. That designate and distinguish atomic orbitals. And distinguish atomic orbitals and electrons present in an atom. Okay. So with the help of these numbers, I can understand which is what and which electron will be where. Okay. So we have 4 quantum numbers. We have 4 quantum numbers. 4 quantum numbers. Today I am going to give you only the name. Number 1 is principal quantum number, which we have just come across in 2n square formula. Principal quantum number represented by n. Number 2 is secondary quantum number or azimuthal quantum number. Azimuthal quantum number represented by L. Third one is magnetic quantum number. Magnetic quantum number usually represented by M. And last one is electron spin quantum number. Or simply spin quantum number as well. Electron spin quantum number. Okay, represented by ml. ml represented by ml, but you will find in some book it is also given as s. So s also works. Okay, this is electron spin quantum. So 4 types of quantum numbers are there, which everyone has its own designation. That means everyone will be representing something of the axis. These 3 are solutions of Schrodinger equation. Schrodinger equation. Okay. This 4th quantum number is not a solution of the Schrodinger equation. Okay. Please take care of this. So the question can come, which quantum number did not come from the solution set of Schrodinger equation? Then answer will be electron spin quantum number, because it was introduced later on, not to prove certain rules that will come later on. It's Polish exclusion principle, Hund's rule. This rule is supposed to be proved. So one we have to introduce. Clear or not clear? So I think we have covered all the topics that were supposed to be covered today. Wrong page. Orbital concept done. Auxiliary quantum numbers clear. So that is all that we had to discuss today. Please keep on reading and please keep on practicing, because if you stop reading then you will also forget everything, and then in exam you will be blank, right? So keep reading, don't forget. Okay, so that's all today. We'll meet in the next lecture. So thank you for joining throughout the lecture. We'll meet again in the next lecture. Till then, keep reading.